my name is Milo, and over the summer, I've been designing an open source viewer for DNA vectors. BreedBase, which is a site that I'm designing this for, is a breeding management and analysis platform widely used for its tools like field design and phenotypic data collection. There's a small problem though. It doesn't have any tools for viewing DNA vector constructs, which is essential for data interpretation for complex genetic data. So my project aims to fix that by building a user-friendly, interactive DNA vector viewer to enhance data interpretation in plant breeding research. So I use 4 main technologies to do this. 3 of them are HTML, JavaScript, and CSS, which work very well together. HTML generally builds the structure to the page. JavaScript implements interactivity, and CSS styles it. The 4th tool I used was D3, which binds data to visual elements. This is an example if you want to come up. It has the HTML here, the D3 and the JavaScript binding this data set to this text element, and then it being styled by CSS, and that gives us this example. Using these 4 tools, you can create a wide range of features, which is what I did. So in the vector viewer, you have the name and the length in base pairs of the vector, and then you have the vector itself here, and then genes that can be labeled with the direction of the genes labeled as triangles here. Then you have the restriction enzyme sites, which go around the vector, I mean. You have restriction enzyme and gene tables, which hopefully in the future will be able to be edited in real time to change the vector itself in real time. Figure 5, 6, and 7 show how the click to drag highlight feature works. You can highlight, and then it'll show the start, the end, and the length in base pairs of the highlighted segment, and then you can delete it by clicking update/reset. Another thing that we hope to do is be able to copy and paste the highlighted segments, and also we hope to be able to delete them. Figure 8 and figure 9 show how you can zoom in and zoom out using the plus or minus button. And then figure 10 shows how you can locate any point on the vector by just hovering over the vector, and it'll show you a number, which is base pairs into the vector. So looking forward, we want to be able to integrate data from GenBank into BreedBase, and specifically the vector viewer. We also want to be able to save vectors to the BreedBase servers. Another feature that we would like to add is adding a collapsible section where you can read the whole sequence, and whenever part of the vector is highlighted, the corresponding sequence is highlighted, and whenever part of the sequence is highlighted, the corresponding vector segment is highlighted. And then the final step would be to implement the vector viewer in the BreedBase. So thank you to BTI, thank you to Lucas Mueller and the Muir Lab, and thank you to all the collaborators for the support and help throughout the summer.
Thank you so much. This is really, really interesting and very complex ideas, and you explain things very clearly and accessibly. So you're a high school student, is that right? So I'm curious, do you think you might want to continue with research in the future as you look to college and beyond that?
I think definitely this experience at BTI has really showed me what research looks like, and what I might expect to see if I want to continue research. And it's very appealing doing research in the future, because I thought that I think that I might have a lot of fun doing this, and I also want to explore more of the world, and I want to solve problems. So I think research would be a good fit for me. Yeah.
That's great. That's great to hear. Clearly, you have a bright future ahead of you. So thank you so much for sharing your research with us. Great. Thank you.